Normal distribution can be used to find areas related to a given z-score. This video will cover how to find areas in the standard normal distribution using a standard normal distribution table. A standard normal distribution table, such as this one, is called a left-tailed table. This means that the table will show the area to the left of any z-score. For example, suppose we are trying to find the area to the left of z equals negative 1.16. Looking at the table, we find the side with the negative z-scores. To look up negative 1.16, we first look up negative 1.1, and then we look over this row to find 0.06 to add on the hundredths place. We can see here that the area to the left of negative 1.16 is 0.1230. So the area to the left of negative 1.16 in the standard normal distribution is 0.1230. This is equivalent to saying that the probability that a z-score is less than negative 1.16 is about 0.1230. Since this distribution is continuous, this is also equivalent to saying the probability that z is less than or equal to negative 1.16 is this same area. Now, suppose we are looking for the area to the right of another z-score, like 0.87. Since the normal distribution table specifically shows us areas to the left, we will not get the area directly from the table. If we go to the normal distribution table and look up 0.87, we need to go to the positive side. We look for 0.8, and then we look over to 0.07. And we see that the area to the left of 0.87 is 0.8078. If we draw this distribution, it looks something like this. 0.87 standard deviations is to the right of the mean. What we are looking for is the area to the right of this z-score. What we found when we looked this up on the table was the area to the left over here. Since we want the blue shaded area, we'll recognize that in any distribution, the entire area must add up to 1, or the sum of all of the probabilities must be 1. So we can use the complement to find the area to the right. In this case, the area to the right will be 1 minus 0.8078, or 0.1922. This again is equivalent to saying the probability that z is greater than 0.87 is 0.1922, or the probability that z is greater than or equal to 0.87 is 0.1922. Now suppose we're looking for the area between two z-scores, or the probability that a z-score falls between two z-scores. So something like this. The probability that z is between negative 2.01 and positive 1.09. Again, the table will give us all areas to the left of a z-score. Negative 2.01 is to the left. 1.09 is to the right and not as far. We are looking for the area between these two z-scores. Again, we're limited to the table telling us the area to the left of any z-score. If we look up the positive value, 1.09, we will see that the total area to the left of 1.09 is 0.8621. Again, this is the area all the way to the left of 1.09. This includes everything to the left of 1.09, including this area that is not shaded. However, the unshaded area is the total area to the left of 2.01, negative 2.01. If we look up negative 2.01's area to the left, we see that it is 0.0222. Again, this is this area that's unshaded. To find the remaining area in between, we simply take 0.8621 and we subtract 0.0222. What remains will be the area just in between negative 2.01 and 0.0222, which equals 0.8399. So the table will give us the area to the left of a z-score. If you are looking for a probability that involves a less than or a less than or equal to, the probability can be found by directly reading off the table. To find areas to the right, or probabilities involving greater than or equal to, the area can be looked up on the table and then subtracted from 1. If we're looking for the probability between two z-scores, we will need to look up both z-scores and subtract the larger area minus the smaller area.